Okay, so what we're going to look at today is transformations of quadratic functions. So we're going to do a lot with quadratic functions, so hopefully you get really comfortable with these. So the first thing we want to look at is if your quadratic function is in standard form, it looks like this. It looks like ax squared plus bx plus c. A, b, and c are all coefficients. They're all numbers. And then what makes it a quadratic function is this x squared right here. So if you're given a quadratic function in standard form, we know the y-intercept immediately. This c term, that constant term, is our y-intercept. And so we find the coordinate 0, c, and that's our y-intercept. The second form that we can write a quadratic in is vertex form, and that means that we can find the vertex from it. And so it looks like a times x minus h squared plus k. So between these two, they both have an a, they both have a squared, and they've both got your x and f of x. And vertex form tells you the vertex, so your vertex is hk. Go ahead and notice that your h in the formula is negative, but in the coordinate it's positive, and k is the same sign. So when we're using that, just make note of that. The negative inside the parentheses tells you to switch the sign of the x-coordinate of the vertex. So that's all that means. H is opposite. All right, so if we look at the examples, we're going to state the form of the quadratic function is vertex or is it standard, and then we're going to identify the characteristic without performing any calculations and without using a calculator. So in this first one, you've got negative 2x plus 7 squared plus 8. It's got those parentheses, so that's a dead giveaway that it is vertex form. And vertex form tells us the vertex. So opposite h, k stays the same. So our characteristic is the vertex, and it is at negative 7, 8. And you can always check yourself using Desmos, but you shouldn't need to. In the next one, we've got 5x squared minus 6x minus 2. There are no parentheses, and so we find that it is in standard form. And the characteristic for that is the y-intercept. And it just comes from our c value, so my y-intercept is 0, negative 2. And again, you could check that with Desmos. Third thing, we've got y equals negative 2, x minus 2 squared. We've got those parentheses, so we can say it is vertex form. Vertex form needs the h and a k. There is no k present, but if we do a little bit of mathemagic, we can add a 0 there, and we actually find that our vertex opposite h, so positive 2, is 2, 0. So that means it's on the x-axis. When we have a quadratic function in vertex form, so it looks like this, we also can identify the transformations. So if there's a negative in front, if a is negative, we've got a reflection over the x-axis, which means it is flipped over. So instead of being a minimum, it's a maximum. And then, depending on what our h is doing, if it's positive, my function is translated left h units. And if it's negative, we go to the right h units. So that's inside the parentheses, we shift horizontally left and right. The k tells us whether we go up or down. If it's positive, we go up k units. If it's negative, we go down k units. All right, and then our dilation. So over here, we've got reflections and translations. These are rigid motions. Which means that they are changing location, not the shape. Over here with dilations, these are our non-rigid motions, which means that they are changing the actual shape and size of it. So if we have a whole number, if a is greater than 1, we have a vertical stretch. And if a is less than 1, so if it's a fraction, we have a vertical compression. So a vertical compression makes it wider. A vertical stretch makes it skinnier. Oh, you can't see that. So using that information, we are given several functions in vertex form, and we are going to identify the vertex and the transformations. So you can always check this on Desmos and compare it to your parent function x squared and see which way it moves. So we've got 3 times x plus 1 squared plus 1. My vertex, opposite of what's inside the parentheses, negative 1. Outside the parentheses stays the same. This 3 in front is my a value, so that means we've got a dilation occurring. Since it is a whole number, it's greater than 1, we've got a vertical stretch by a factor of 3. This plus 1 inside the parentheses is the same thing as a plus h, so we are going left 1 unit. Left 1 unit, and this plus 1 tells me I'm going up 1 unit. Left and right are opposite of what you think, up and down is the same. All right, in the next one, we've got a vertex at opposite h, k stays the same, so 5, negative 3, and you can always check that in Desmos if you need to. We have a negative in front, which means I've got a reflection over the x-axis. We have a fraction coming next, which means we have a vertical compression. By a factor of 2/3. And we've got a minus 5 in parentheses, which means we go to the right 5 units. Minus 3 outside, which is down 3. All right, in number 3, what happens is that we don't actually have parentheses, but it's still technically in vertex form. It's kind of a combination of vertex and standard. But what we can do is we can rewrite it saying, well, x plus 0 squared plus 12, and now we have a placeholder for h. So my vertex is 0, 12. That negative in front tells me a reflection over the x-axis. And that plus 12 tells me that I go up 12 units. Excuse me. All right, looking at example 4. We've got a fraction in front, we've got parentheses. My vertex, there's no k, so we'll put a 0 as a placeholder. My vertex would be 9, 0. 4/5 in front tells me a vertical compression. And that minus 9 inside the parentheses means that I'm translating to the right 9 units. So that means your original vertex at the origin is going 9 units to the right. So it's still positive. All right, my vertex in the next one, opposite h, k stays the same. So we've got negative 1, negative 6. So that would be down in quadrant 3. So think about how it's shifting from your original vertex at the origin down to negative 1, negative 6. So we know that it's going to the left and down. Left 1 unit, and we've got down 6. All right, and then the last one, we've got all the tricks in there. So vertex, opposite h, k stays the same, so we've got 7, 10. We've got a negative in front, so a reflection over the x-axis. A 2 in the front tells me, since it's greater than 1, we've got a vertical stretch. So that means the graph is getting taller and skinnier. Inside the parentheses tells me left or right. And so since we are subtracting, we go to the right 7. Plus 10 outside the parentheses tells me I'm going up 10 units. So this up here is really good information to know. Study that, memorize that. We'll practice with that a lot. You can also apply these transformations to other functions. So if you can learn it now, it'll be easier when you get some different functions. On the back, we do a little bit more, so we're going backwards. So we are given the transformations, and we have to write the function in vertex form. So if we've got a reflection over the x-axis, we know that it's negative in front, compression or stretch comes next. If we go to the left or right, we need parentheses. Since we go to the left, we'll start our parentheses. We go to the left, so we add. And to make it a quadratic function, we have to have that squared. And we've got all our transformations there. And the next one, a vertical stretch by a factor of 5, starts out our function. If we go to the left or right, we need parentheses, so we do. If we're going to the right, we subtract. We subtract. Square it, and then if we go up, we add 2 on the outside. Make sure it's squared, make sure you've got your x in there. The next one says standard form. So we've got a vertical reflection, so we've got a negative in front. Vertical compression by a factor of, I believe that should be 4/5. So we'll have a negative 4/5. And then it's translated down. So since we don't have any horizontal left or right movement, we don't need parentheses. So we've got negative 4/5 x squared minus 5. And then what we're going to do is go from vertex form to standard form. So given our transformations, we're going to write it in vertex form, and then we're going to use some algebra and get it in standard form. So if we've got a vertical stretch by a factor of 2, we'll have our 2. If we go to the left or right, we need parentheses, so we'll have x minus 4 squared. Since I'm going down, I subtract 1. So then we're using order of operations. We have done this before, and we are going to simplify and expand so that we get it in standard form. Following order of operations, we want to do that x minus 4 squared first. So in our box, we'll have x minus 4 and x minus 4. Multiply it out. If you prefer FOIL, you can do that. And we are going to replace that x minus 4 squared with x squared minus 8x plus 16. And you can always pause the video so you can work that out. I know I went through that a little quick. And then next thing we're going to do is distribute in that 2. And then we'll simplify in that final step to get our standard form. Make sure it's in descending order. So not too bad, we're just combining some previous skills. So in 11, what we are going to do is write it in vertex form. So if it's reflected over the x-axis, we start with a negative. If we've got left to right movement, we do our parentheses. Since I go to the right, I subtract 3. And then since I go up, I add 7. So following order of operations, we are going to take care of our x minus 3 squared first. So we'll go ahead and draw our box. Multiply that out. And again, if you prefer to FOIL, you are more than welcome to do that. Pause it, work it out yourself. And then we are going to replace, substitute in that multiplied function. Keeping our negative in front, keeping our plus 7 at the end. So then next thing we'll multiply, we'll distribute in that negative. We'll have a negative x squared plus 6x minus 9 plus 7. Last step, we'll combine like terms. So standard form, we've got negative x squared plus 6x minus 2. And what you can do to make sure that your algebra is correct is plug both of these functions, the negative x minus 3 squared plus 7 and the negative x squared plus 6x minus 2 into Desmos. And then if your graphs are on top of each other, then you know that you did it correct and it's graphing the exact same function. The last one for this video, we've got a reflection over the x-axis, so we'll start off with a negative. We have a vertical compression, so we'll have a negative 1/3. If I go left or right, I need parentheses. Since I go to the left, I do need them. Left, we add, and we go 1 unit up. Make sure you've got that squared in there. Make sure you've got the x in there. So just like the rest, we are going to multiply our binomial first. So x plus 6 times itself. Pause the video and work that out if you need to. And we are going to replace that in there so that we can continue with order of operations. And hopefully when I give you these and I've got a fraction there, I'll make it really nice and so it will divide evenly. So when we distribute in that negative 1/3, we'll have a negative 1/3 x squared, a negative 4x minus a 12 plus 1. And last step to get to standard form, we will combine like terms. We'll have a negative 1/3 x squared minus 4x minus 11. Look for the next video where we use Desmos to go from standard form to vertex form.